Here you go. Okay. Okay, I'll wait for Zahid to come back, but I think we can randomly throw out the answers, yeah, for CCL4. Okay, let's start with the first sentence. What's the first sentence for CCL4?
Carbon atom has an electron arrangement of 2,4.
Very good, correct. Carbon atom has an electron arrangement of 2,4, correct? Very good. What's my next sentence after that?
The valence electron of carbon is 4.
Very good. The valence electron of carbon is 4. Well done. So the first two sentences there is correct. Okay, Siddharth, since you're already saying for that, carry on.
Chlorine atom has an electron arrangement of 287.
Okay.
And the valence electron will be 7.
Okay, correct.
The same ayat lecture just now.
Okay, same sentence. So did you all get that 4 sentences there?
Yes.
Yes.
Okay, good. Now, can I carry on? Okay, what will come after that? What will be the answer after that? Okay. What's my third paragraph answer?
Carbon atom needs.
Carbon atom needs.
Yeah, it's fine. Irina, go ahead.
A carbon atom needs 4 more electrons to achieve SOEA.
Correct. Carbon atom needs 4 more electrons to achieve SOEA. Correct for that one. Okay, carry on.
Teacher,
yeah.
Can you give me a minute to go and find my paper?
Okay, go ahead.
I can't find it.
No worries, go ahead. Okay, then rest of you. Irina, continue.
A chlorine atom needs 1 more electron to achieve SOEA.
Very good. A chlorine atom needs 1 more electron to achieve SOEA. Very good. Okay. Can I have Heyman continuing?
Okay, so just now, wait, what was the last sentence just now, sir?
What are you doing, Heyman?
I'm finding my paper. What was the last sentence just now, sir? SOEA. So one carbon atom and 1 chlorine atom, they are attracted by strong electrostatic forces to form CCl.
Really?
Sorry. No, sir.
Non-ionic bond.
You can very well see that Heyman is not here. Heyman, what are you doing and where are you?
I am here.
Physically, but not spiritually.
Exactly.
Oh, sorry, sir. Having some thoughts. Sorry.
Okay, come back. That's why I like calling names, so that you can pay attention.
I can't find my paper.
Okay, doesn't matter. Don't want to waste time. Neela, go to you, Neela.
Each carbon atom, each chlorine atom needs 1 more electron to achieve. So I wrote here SDEA. I don't know what's SDEA.
Stable.
I think you meant stable.
Duplet electron
arrangement. Duplet electron arrangement.
Yeah. But why do you want to get stable duplet?
It's supposed to get SOEA.
SOEA, isn't it?
Yeah. Okay.
Okay. All right. Go try that again.
Each chlorine atom needs 1 more electron to achieve stable octet electron arrangement.
Very good. Okay. How about each carbon atom?
Each carbon atoms needs 4 more electron to achieve stable octet electron arrangement.
Okay, did you all do or not the question?
Yeah, I did.
Okay, correct. Her answers are correct. Okay. Now, is there anything else after that?
The drawing.
Okay, then you draw, right? I really like the drawing, and they like to ask this question during exam. C will be in the middle. CL, 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 CL. Okay, who drew it? Can y'all just show on the screen so your friend can see it? Let me just check.
And see ya.
Okay, yes, yes, it is something as ugly as that.
Ayo, sakit hati.
No, just show. See that, show. It is ugly. Not your work ugly, but it looks like that. Okay, everyone see that's work.
Sekejap.
Okay, so that is correct. Are we clear?
Where's Sidat?
Oh, you haven't seen.
Have y'all found
I'm
Sidat?
here.
Okay, faham.
Okay. So can look at Sidat, don't move. Show it back again.
Leave the paper.
Yeah, the paper,
Okay.
yes. You see this carbon has one. Can y'all see my cursor? No, right?
No.
What, sir?
No, sure.
No.
Can you see my cursor?
No. No, sure.
Okay, doesn't matter. So anyway, he's got 4. Carbon has 4, and the chlorine shares 1 with each carbon. Can y'all see that?
Yes.
Okay, so CCl4 is a very famous SPM question. Are we clear? Okay, now we'll stop at CCl4. Thank you, Siddharth.
Okay, sir.
Okay, eyes on teacher. Today I'm going to teach you 3 new things that has never come out in Form 4 syllabus before. Number 1 is called your hydrogen bonding. Number 2 is your dative bond. Number 3 is your metallic bonding. Okay, they're all very easy. They're not difficult, but
Why teacher mute?
sorry. I was pressing the admit button. Okay, these 3 things. Okay, I'm gonna share my slide with you. Open up your textbook. Okay, open up your textbook to hydrogen bonding. I'm just gonna share my slide with you. Okay. Siddharth, it's very cute to see you with your hairband.
Hairband. Yeah, I can't comb my hair.
Okay. Now, if I ask you what's hydrogen bonding, would you think that hydrogen is when a hydrogen is reacting with another hydrogen? Would you think that?
No.
Would you consider that as your hydrogen bonding?
Yeah.
Okay, if you don't look at the textbook, and you hear the word hydrogen bonding, what will come to your mind?
Hydrogen.
Hydrogens. Yeah.
Okay, correct. Very good. Yeah. So I just want to show you. Can you see my slide?
Hydrogens combining.
Correct. Very good.
Yes.
Okay, you can see teacher's slide. So let's read properly. When a hydrogen atom is covalently bonded to a highly electronegative atom. Okay. Now, if you studied in chapter 4, you would learn that going across my period. Okay, going across the period means from group 1 until group 18. That is going across my period. Okay. Now, when you're going across the period, the electronegativity increases. What is the meaning of electronegativity? Did you all do group 4?
You will receive electron, right?
Very good. Okay, electronegativity means the ability to receive electron. So in group 1, in group 2, I donate electron easily, correct?
Yeah.
Yes.
Group 17, group 16, I will receive electron more easily. Can you understand?
Yeah.
Okay, because it is group 15, group 16, group 17, memang I kekurangan electron and I need electrons to become stable, correct?
Yes.
So that's why I am more electronegative at group 15, group 16 and group 17. So here, when a hydrogen atom is covalently bonded to a highly electronegative atom, so this X here can either be from group 15, group 16 or group 17. Okay, the shared pair of electron will be, what is that? Let me see, I can't see the word there. Will be drawn away from the hydrogen atom, causing it to acquire a partial positive charge. Don't worry, later I'll teach you. The hydrogen atom can form a hydrogen bond with another very electronegative atom, which has a lone pair of electron. Okay, the most important thing you need to know is that when you want to form a hydrogen bond, that atom must have a lone pair. Your X and your Y can be fluorine, which is in group 17, oxygen in group 16, nitrogen in group 15. Open up your textbook, go and look at your periodic table. Is it correct? It's group 17, 16, and 15. Go and check.
Habis.
Okay, go and check your periodic table.
Yeah.
Is it this 17,
17,
16, and 15?
15.
Yeah.
Okay, correct. So remember, your highly electronegative atom can only be phone. Your phone, F-O-N, phone. Fluorine, oxygen, and nitrogen. Okay. So these hydrogen bonds are actually stronger. This is not important for you. This is form 6. Okay. So again, not important. I want to show you an example. Okay. Now, look. This is a hydrogen and this is an oxygen. This hydrogen and this oxygen from another atom. Hydrogen from one atom. Wait, yeah. Sorry. Wait, sorry. What did I do? Hang on, yeah. Let me just admit somebody else. Okay. Pointer options, yes. Okay. This hydrogen will come from one atom, one molecule here, and this oxygen from another molecule. I will form my hydrogen bond. Are you all seeing that?
Yes.
I repeat, one hydrogen comes from one molecule, another oxygen comes from another molecule. I get a hydrogen bond.
Yeah.
Okay, the oxygen must come from one molecule, the hydrogen must come from a different molecule. Then what happens is you are going to get a hydrogen bond. Cannot be this hydrogen, look at where my teacher's pointer is. Cannot be this hydrogen and this oxygen having a hydrogen bond. No such thing. Cannot be from the same molecule. Must be intermolecular. Do you get, teacher?
Okay, Cha.
Yes.
Yeah.
Okay, hang on. Let me just go back to normal to know what you all are seeing. Okay, here. Now let's look at nitrogen and hydrogen. Again, my nitrogen is here. Okay, I got a nitrogen here. Okay, and I got another hydrogen here. One nitrogen with my lone pair of electron and one hydrogen here. This one is my hydrogen bond. Again, I have another nitrogen here and another hydrogen from here. I will get a hydrogen bond here. Are you following, teacher?
Yes.
Okay, now let's look at this hydrogen here and my fluorine here. Okay, hydrogen and my hydrogen from one molecule and a fluorine from another molecule. This will be my hydrogen bond. So hydrogen bond I only can form between hydrogen and three things. What are those three things?
Oxygen.
Oxygen.
Oxygen,
Fluorine,
nitrogen.
oxygen, nitrogen.
Very good. Fluorine, yeah? Three things. Fluorine, oxygen, nitrogen.
Nitrogen.
Okay? All right. So, hang on. All right. Let's take out your module. We do some questions in the module itself. Take out your module. Okay. It is on page 80. Page 80. Okay, what is electronegativity? Okay, as I said just now, electronegativity is the strength of an atom to attract
Electrons.
electrons. I want to attract electrons to my nucleus. Okay, so that's why I call it electronegativity. Heyman has a problem. What's your problem, Heyman? Heyman's module is in school. Very good. Can someone snap a photo and put in the class group of the first few pages we are doing? A kind soul, help him. Okay, now what is a polar molecule? Okay, let's look at the word polar, not polar bear. Huh? Okay, a polar molecule is a molecule containing polar bonds. Not polar bear, still polar bonds. Okay, how do I form a polar bonds? When I have a difference between the electronegativity of the atoms participating in a bond. I pity y'all lah, kesian y'all. Form 6 y'all learning now already. But too bad lah. Okay, so let's look at hydrogen chloride. Hydrogen chloride is a polar molecule. Why is hydrogen chloride polar? Because chlorine atom here is more electronegative. Now you look at all this. Now chlorine, right? Remember we did this in the covalent bond. I have one electron here, correct? Where teacher's cursor is? Where my cursor is, yeah, where my, can you see my,
Sir, cannot see.
yeah, sorry, only PowerPoint can use pointer. Wait, let me just figure out, hang on. Okay, hang on. Oh, also I can't. Wait, give me a minute. And, okay. Oh, I still can't. Oh, I can't draw on this. I'm so sorry. Never mind. Okay. Can you see where this CL, where there's, can you see there's dots all over the CL here?
Sir, it's still on the PowerPoint just now. The
Yeah.
hydrogen bond.
Oh. Okay. Wait. Hang on. Thank you for telling. Now do you see?
Yeah.
Okay.
Yeah.
La. I didn't know you all didn't see. I go back to the first one. Electronegativity is the strength of an atom to attract electrons. Okay. So who in class can attract girlfriends easily? That is the most electronegative.
Nadia.
Nugget.
Nugget.
Okay, Nugget, you're the
Nugget.
most electronegative. So you are fluorine. Who is the second one can attract electrons easily?
Bavi.
Sirat.
Adam.
Bavi.
Okay, Bavi will be
Mo.
oxygen.
Mo.
Okay, then Mo. Okay, Mo, you will be nitrogen. Are we clear?
Yes.
Okay, so Nugget, you are most electronegative. You can attract girls towards you.
Yalah.
Okay. Okay, now next. What is a polar molecule? I'm not going to go to the definition again. I'm going to straight away go here. Okay. Can you see teacher's cursor here? Do you see my cursor?
Yeah. Yeah.
Okay. Now, you and I know, I taught you covalent bond that day. I've got one dot here and one cross here that comes with hydrogen and chlorine, correct?
Mhm.
Yes or no? Now, chlorine is 2.8.7, correct?
Yeah.
Yeah.
Okay, so I got 1, 2, 3, 4, 5, 6. I supposed to have another dot
Two
here, am
more.
I right?
Yeah.
Okay, I'm
Yeah.
supposed to have another dot here. And what is hydrogen doing? Hydrogen shares a cross with me here, am I right?
Yes.
So all of them are stable, correct or not?
Yeah.
Okay, HCl is already stable, but now you look at Cl. At this point here, Cl got so many lone electrons here. All these are called lone pair of electrons. Because I have got this lone pair of electrons, I am very electronegative compared to hydrogen. Are we clear?
Yeah.
Okay, sir.
Okay, so when I have, when I'm more electronegative, I am going to draw this S symbol here. Can you see the S symbol? Your book also got. Your book also got. Your book also got.
Oh, yeah, sir. Yes, sir.
Ayo. Okay, can you see the S minus there?
Yeah.
Yeah.
Okay, because it is very negatively charged, therefore it is S minus. And my hydrogen, because it is very positively charged, it is S plus. It's not exactly S, but I call it S lah because the symbol looks like S there.
Yeah.
Do you understand?
Yeah.
Yes, sir.
Okay, when I got a positively symbol, partial positive on top and partial negative on top, I call this a polar molecule. It's called polar. Why? Because the chlorine atom in the hydrogen chloride molecule is more electronegative. Okay, everyone write down the answer. It is more electronegative than hydrogen. Okay, the pair of electrons are more closer with chlorine atom compared with hydrogen atoms. Okay, that's what they're talking about, polar molecule. Polar means I got partially positive and partially negative. That is what's the definition of a polar molecule. And all the electrons are towards chlorine and not towards hydrogen. When an electron is towards your negative side, it's called more electronegative. Okay, what's an example of other polar molecules? Water, ammonia, sulfur dioxide, sulfur, hydrogen sulfide. Okay, now let's look at the one I just showed you. What is a hydrogen bond? When a hydrogen is covalently attracted to fluorine, oxygen, and nitrogen, the hydrogen bond is an attraction between the hydrogen atoms with the electronegative atoms from the other molecules. So let's see, as I said just now, in my water molecule here, my hydrogen, which is partially positive, goes to my oxygen, which is partially negative. Do you all see that?
Yeah.
Okay, that is my hydrogen bond. One must be partially positive, one must be partially negative, both coming from different molecules. That gives me my hydrogen bond. Are we clear?
Yeah.
Yes.
Okay, now we look at this whole picture on the right hand side here. I got one water molecule up there, one water molecule by the side of my right and my left, and one water molecule in the middle. Again, you see the hydrogen, which is positive, will connect to my oxygen, which is negative. That's my hydrogen bond. My hydrogen, which is positive, connects to my oxygen, which is negative. My hydrogen, which is positive, connects to my oxygen, which is negative. Okay, are we clear about that?
Yeah.
Yes, sir.
Okay, now answer the question. How does a hydrogen bond form in a hydrogen fluoride? Fluorine is more?
Electronegative.
Electronegative.
Yes, you all are looking at my answer. More electronegative, correct? So the pair of electrons shared in the bond are more closer with the
Chlorine.
fluorine
Chlorine.
compared to the hydrogen. Okay? So my lone pair of electron is closer to my fluorine compared to my hydrogen. So this leads to the formation of the partially positive charge on the hydrogen and the partially charge on the fluorine. So I'm going to draw my board
Fluorine.
here. Can you see teacher's board?
Only a quarter, now half, now, yeah.
Okay, so have a look. Hydrogen and fluorine. Okay. Now, what they are trying to say is fluorine is more electronegative, right? So
Yes.
here my fluorine will be partially negative and partially positive charge. Why? Because all the electron goes towards the fluorine. So this is more electronegative, this is more electropositive. That's all. That's all they are trying to say. Later I do H and O also. Because this is more electronegative, all my electrons will go towards here. So this is partially negative, partially positive. That's all.
Yeah.
Okay. Now, the partially positive charge of the hydrogen atom is then attracted to the partially negative charge fluorine, known as
The partial particle
Hydrogen bond.
hydrogen bond.
hydrogen bond. So what you are going to see here is, wait, I'll show you my board again. So at least you can see. Okay. So our teacher got HF. Okay, this is partially positive, this is partially negative. All of you agree? Can you see?
Yes.
Yes.
Okay, then I have another HF here. Okay, again, this is partially negative, this is partially positive. This H, which is partially positive, will form a hydrogen bond with this F, which is partially negative. This is called my hydrogen bonding.
Understand.
It's
Now.
the same thing with what oxygen is the same thing with nitrogen. Okay?
Oh, okay, now I understand.
Yeah, my whiteboard very important, right?
Yeah.
Gotcha.
Thank God
Very
for Jude's whiteboard. This one. We were arguing just now. Can
Oh.
I have my whiteboard or not? He doesn't want to give it to me.
Thank you, Jude.
Thank you, Jude.
Okay, next. Okay, let's go to ammonia, nitrogen. So nitrogen or hydrogen, which one is more electronegative?
Nitrogen.
Okay, nitrogen. Very good. So the pair of electron, okay, I give you an example. Nugget and nugget is
Haris.
more electronegative, right? Nugget and the one lah Haris. Nugget and
Durga.
Payment. H also.
Amen.
I'm trying to be fair to all, okay? Nugget and
Durga.
Superman. Okay,
Superman.
Nugget is more electronegative compared to Superman. Sorry, Superman.
Weak lah Superman.
All right, so my point here is because Nugget is more electronegative, all the girls want to go to Nugget compared to Superman.
Yes, understand.
Do you get the concept now?
Yeah.
Okay.
I'm not gonna forget this
Yeah.
concept.
Okay, sorry, Superman. Okay, I got 2 minutes faster. I wanted to finish it fast, but never mind. Nitrogen is more electronegative than hydrogen. So all the girls, the pair of electrons will be close towards nitrogen,
Yeah.
Nugget compared to Superman. Okay, nitrogen and hydrogen. Again, the same point. The partially positive of the hydrogen will be attracted to the partially negative of the
Partially
nitrogen to form hydrogen.
Hydrogen
Hydrogen bond.
Okay. Now, what is the main point? How can my hydrogen bond affect the boiling point? Okay, eyes on teacher, yeah? Eyes on my board, actually. Can you see the board?
Yeah.
You see, yeah? I already have here a certain, let's say I got 80 degrees Celsius, my melting and my boiling point, okay? Okay, on top of that, suddenly now I got extra hydrogen bond here. I need more energy to break the bond. So will my boiling point increase?
Yeah.
Yes.
Yes.
Yes. So if you look at the example of propane and ethanol, propane got no hydrogen bond, but ethanol got hydrogen bond because got O and got H here. Okay, but both of them got about the same amount of relative molecular size and molecular mass and size. Okay, but we can see that my boiling point for ethanol is higher than propane. Do you understand?
Yes.
Why? Why? Because ethanol has a hydrogen atom attached to the oxygen. So when I got a hydrogen with an oxygen, what bond is that?
Hydrogen bond.
Okay, there are hydrogen bonds between the ethanol molecules. So more energy needs to
Be broken down.
break the bond. Okay? Break the bond. Okay, it's going to go off anytime soon. I will send you another link. You can't use the same link because I didn't schedule it.
Okay, sir.
Okay,
Okay.
once it goes off, can you try the questions for me on page 82 and page 83 while I come back? Because I need to save this also for your friends.
Okay.
Okay.